Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about Abelian group and group examples. In our last class, we clearly discussed about what is meant by monoid and group. Please watch that class and come back here. The link for the playlist is provided in the description below. Coming to today's class, so first we will understand the definition, then we go with few examples to understand the better understanding of the Abelian group. Abelian group, a group G star is called an Abelian group. So before checking for Abelian group, first we need to check for whether the given set and the binary operation is a group or not. So what's the conditions we need to check for group? That discussions made previously. So if it is an Abelian group or commutative group, when we are saying it as commutative group or Abelian group, if it satisfies the condition A binary operation B equal to B binary operation A for all A comma B belongs to set A. Here we have mentioned it as set A, usually set G. This is the commutative property. The set and the binary operation, if it satisfies commutative property, then we accept it as an Abelian group. With example, you are going to understand it better. For a group, you need to check the four conditions. What's that four conditions? Closure, associative, identity element should be there, and inverse should be there for each and every element. If it satisfies these four, we say it as a group. If the fifth one is also satisfied, we say it as an Abelian group. What is the fifth one? Commutative property. Now coming to the example, the first example is set of all Z means set of all integer values, means minus infinite to plus infinite, and the binary operation here is plus is considered as the binary operation. First we need to check one by one. So the closure property, whether the set and the binary operation, is it satisfying the closure property. What is closure property? You take any two elements, add those two elements, 1 plus 5, 6. 6 is the element that belongs to set Z. Z means set of integers. You take any two integers, if you add them, you are going to get an integer. So it is satisfying a closure property. The second one is associative property. Addition always accepts associative property. You take A plus B plus C is same as A plus B plus C. Both are same. You are going to get the same output. So it is satisfying associative property. What's the identity element in the set Z? 0 is the identity element. Any number A addition 0, you are going to get the A. So 0 is considered as an identity element for addition. Similarly, do you have an inverse for each and every element? Yes, we are having inverse for each and every element. A addition minus A is equal to 0. Inverse element means A binary operation minus A. You are going to get the identity elements. That is what we say, these two are inverse of each other. For A, minus A is inverse. For minus A is inverse. So A plus minus A is equal to 0. And is it satisfying commutative property? Yes, it is satisfying. Addition will satisfy commutative property. A plus B equal to B plus A. Both are same. So all the five properties are satisfied. This set we call it as a Abelian group. Similarly, one more example we are going to discuss. The question goes like this. The set of all cube roots of unity is an Abelian group with respect to the operation multiplication. So what is meant by cube roots of unity? The cube roots of unity are 1 omega omega square. So what are these? These basics we discussed in our +1 +2 mathematics. So please watch our mathematics playlist for +1 and +2. There we have discussed all these basics. Here we are not going to show it. Our aim is to show here it as it is satisfying a group property. So 1 omega omega square. These are the cube roots of unity. So now we have to construct the property table. 1 multiplied by 1, 1. 1 multiplied by omega, omega. 1 multiplied by omega square, omega square. Similarly, omega multiplied by 1, omega. Omega multiplied by omega, omega square. Omega multiplied by omega square, which is omega cube. Omega cube means 1. from the cube roots of unity. This is the basic from the cube roots of unity. Omega cube means 1. Similarly, omega square multiplied by 1, omega square. Omega square multiplied by omega, omega cube means 1. Omega square multiplied by omega square, omega power 4 means omega cube multiplied by omega. Omega cube means 1. 1 multiplied by omega, omega. So we have got omega. This is the operation table. From this we need to check for 5 properties. What are those? Closure property. First one is it satisfying the closure property? Yes. You take all these values. We are having only values 1, omega, omega square. You do any operation, binary operation on these 2 elements. We are going to get the elements that belongs to 1, omega, omega square. It is satisfying the closure property. That is what closure property says. Is it associative? Yes. Multiplication is associative. 1 multiplied by omega square, which is same as 1 multiplied by omega square. You are going to get the same output. Similarly, do you have identity element here? Yes, identity element is there. For multiplication, 1 is the identity element. 1 multiplied by 1, 1. 1 multiplied by omega, omega. 1 multiplied by omega square, omega square. So you multiply with any number, you are going to get the same number. So 1 is the identity element. Do you have inverse for all the elements? Yes, we are having inverse for all the elements. For omega square is going to get the identity element. Omega multiplied by omega square, which is omega cube, means 1. For omega square is the inverse. For omega square, omega is the inverse. For 1 is the inverse. For every element, we are having identity. Similarly, is it satisfying commutative? Yes, it satisfies commutative. Multiplication satisfies commutative. Omega square is equal to omega square multiplied by omega. Both are same. So this we say it as abelian group. Similarly, we do one more example for better understanding. Given the operation table, they have given some binary operation dot. Show that the operation dot is a group on set A is equal to A, B, C, D. That binary operation is given in the form of table. First we need to identify this table, understand this table, then we have to check for all the properties, 5 properties. What are those? Closure, associative, identity, inverse and commutative. Then we say it as abelian group. So now check this. Is it closure property? Yes, it is closure property. It is satisfying closure property. All the elements that belongs in the operation table, A dot A dot B, A dot C, A dot D. Whatever the elements present here, they are all of A, B, C, D. Means the elements that present in the group, in the set A. So it is satisfying closure property. Similarly, is it satisfying associative property? Yes, it is satisfying associative property. We have shown one example. You check the remaining examples. A dot B dot C equal to A dot B dot C. What is B dot C? B dot C is a D. A dot D. So the output here is D. Similarly, you do this, you are going to get D. Both are same. Like this, you are going to get associative property for all the 3 values. You take any 3 values from the set A, B, C, D, you are going to get, it is satisfying the associative property. Similarly, the next one, what is the identity element here? See here, A is the identity element. A dot A dot B, A dot C, A dot D. Similarly, A dot A, B dot A, B, C dot A, C, D dot A, D. A is acting as an identity element. Similarly, we need to check for inverse. We are having inverse for all the elements. For A is the inverse because A dot A you are going to get. For B, D is the inverse. B dot D is identity element. Similarly, D dot B is identity element. So C is the inverse. You check the table, you are going to get C, inverse is C. And it is satisfying the commutative property also. A dot B, B dot A, B. Both are same. For any 2 values, commutative is satisfying. So this we can call it as an abelian group. Like this, we need to check these type of examples are going to be asked in the exam. Hope you understand the group examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.